research right. The next talk is by Hwang from OLEDON. This is an early stage company that develops a very high PPI deposition solution for OLED microdisplays that's up to 10K. This is one of the problems with OLEDs today, the limited deposition density that one can achieve. This is one possible solution from Korea's OLEDON. So Chris, you have the stage.
Yes, I am here. Can you listen me?
Yeah, very well. Hello.
Okay, can I go ahead?
Yeah, go ahead. I'm here,
So,
just without the
am
video.
I sharing my screen? Is okay?
Yeah.
Okay, thank you for having me. I'm so honored to be able to present today. I am developing high resolution evaporator for the mass production of OLEDOS microdisplays. My target resolution is going to be 10,000 ppi. So my discussion is going to be about high resolution evaporation source, high resolution fine metal mask, high resolution vision aligner, and the high resolution FMM evaporator. These days, the mobile computer has been evolving to a spatial computer using semiconductor displays. So OLED powder molecules will be landing on the surface of a silicon wafer to provide tiny displays, what is OLED on silicon. The fabrication of RGB OLEDoS is going to have a CMOS fabrication, anode process, and a FMM evaporation process, thin film encapsulation process. Above all, the FMM evaporation is going to give RGB patterns, which will be the most competitive technology as a blue ocean high tech in display industry. So conventional FMM evaporation is going to have a CMOS wafer substrate at the top, FMM in the middle, evaporation source at the bottom. Splitting molecular beam will be passing through the opening of the fine metal mask to provide pattern films on the substrate. We know there is a shadow phenomenon. Organic molecules will be flying into the opening area of the fine metal mask to provide patterns on the glass substrate. Vapor angle was 56 degrees, and FMM thickness is going to give a shadow distance. So the 4.1 micrometer of distance is going to give only 600 ppi on the smartphone or LED display we have now. So in order to go from 600 to 10,000 ppi, the 25 micrometer of pattern size will go down to 2 micrometers more. 4.1 micrometer of shadow distance will go down to 0.1 as a shadow free. FMM thickness is going to be 1.3 micrometer, and then vapor angle should go down to 5 degrees from 56 degrees. Considering fill factor, the patterns active area are supposed to be the same of FMM whole area. However, the 56 degrees evaporation angle is going to give 57% low fill factor because of 4.1 micrometer of shadow distance. 5 degrees evaporation angle is going to give a 98% fill factor, which is quite high. We know the higher fill factor is going to give a lowest power consumption device. The substrate moves in to be aligned with fine metal mask. We're going to have a metal plate down there, which will be evaporating organic molecules in a surface normal direction to provide shadow-free patterns on the substrate. We call this plane source FMM evaporation. So we have done to develop various types of plane sources so far, and then plane source FMM evaporator as well for the first time in the world. The FMM patterns has been studied in point source evaporation and in plane source evaporation. We are finding the 56 degrees evaporation angle goes down to 5.1 degrees. And then following shadow distance has been decreased by 23 times smaller. And then the pattern area has been increased about 3 times wider.